Hello everyone, in this video we'll be solving problem 918 maximum sum circular subarray. The problem statement is we are given a circular integer array nums of length n. We need to return the maximum possible sum of a non-empty array of nums. The additional criteria is that we can include a circular subarray where the last element of the subarray can be tied back to the first element. In example number 1, the output is 3 because we don't need any other numbers besides 3 in the subarray to get the maximum total. While in example number 2, the maximum sum is 10 where we can include the first and the last element in the subarray to get that total. This problem is very much similar to the LeetCode problem 53. The only difference between the two is the use of circular subarray. Before we proceed with the explanation on how to solve this problem, I would highly recommend you to look at the LeetCode 53 solution. The details should be there in the description below. Now let's switch to whiteboard and discuss the solution. Let's use this example. The maximum subarray total for this array is 9, where we are taking the first two elements only. Before we dive into the solution, let's talk through a couple of concepts. As we are looking for the subarray where the elements are consecutive, there are three possibilities for an subarray to exist. One possibility is that the subarray that gives the highest total is at the start of the original array. That is, the start index is 0. Other possibility is at the end where the end index is 0. And the third possibility, it is in the between where the start and the end index are non-zero values. But with circular subarrays, there is a fourth possibility where the elements are at the start and the end of the array. As part of LeetCode 53 solution, we have already covered the first three cases which can be solved using Kadane's algorithm. We just need to adjust the solution to cover scenario number 4. Let's walk through those changes. As mentioned earlier, in Kadane's algorithm, we were using two variables. One is the temporary sum and the other is the maximum sum. Let's use this example to understand the concept better. The sum of all of the elements in the array is 3. Maximum subarray total is 9, which is a combination of 2 and 7 in the center of the array. It will be fair to say that the sum of the maximum subarray plus the remaining elements will give us the total of the entire array. Now assume if the array that is at the center gives us the minimum total of a subarray. So all of the elements to the left and the right side of it, which constitutes the circular subarray, will give us the maximum total of a subarray. So using the combination of the array in the center and the total value of all of the elements in the array, we can calculate the total of the circular subarray. Let me explain this using an example. I'm intentionally using this example where the maximum subarray is actually the circular subarray which have few elements at the start and at the end. So going by that logic, the elements that are in the center will give us the minimum total. If we can figure out the minimum subarray that is at the center using Kadane's algorithm and then compare it with the total of all of the elements, we can easily figure out what is going to be the circular subarray total. If we use Kadane's algorithm to this example to calculate the minimum subarray total, we should get minus 11, which should start from minus 10 and end at minus 1. Now I can compare the minimum subarray total with the total of all of the elements, and the difference between the two values should give me the total of the circular subarray, which should include the remaining elements like the 5 from the start and 3 and 5 from the end. This is how we can solve the circular subarray problem using Kadane's algorithm. Let's walk through one more example to get a better idea how we can implement this approach. The case is when there are all negative values in the array. As we iterate through this array using Kadane's algorithm, we'll be recording three values: the total of all of the elements, the maximum subarray, and the minimum. The total is minus 4, minimum subarray total is minus 9, and the maximum subarray will be 3. That's because we have not included the circular subarray yet, hence 3 is the largest or the maximum subarray. Now to calculate the maximum circular subarray, the formula is total minus minimum subarray, that is minus 4 minus of minus 9. The total is 5. which is greater than the maximum subarray that we have calculated so far. So between the two, we should return 5 as our output. With this solution, our time complexity is O of n, as we are only running one iteration through the entire array to calculate the total, minimum subarray and the maximum subarray. While the space complexity is O of 1, that is constant space, as we are only using these variables to record the values and then using a formula to calculate the circular subarray and return the output. I hope you are able to understand how we modified or tweaked Kadane's algorithm to solve our problem. Let me show you how we can implement this using Java. In the Java implementation, I've initialized 5 variables to record the maximum and the minimum subarray total and the total of all of the elements across the array. After that, I'm starting a for loop to iterate through all of the elements in the array, starting with I is equals to 1. Inside the loop, I'm using Kadane's algorithm to calculate the maximum subarray and minimum subarray. I'm also recording the total of all of the elements across the array. If all of the elements in the array are negative, then the maximum sum will also be negative, that is less than 0. In this case, we don't need to calculate the circular sum. We can simply return max sum as our output. On the last line, I'm calculating the circular sum, which is total minus minimum sum, and comparing it with max sum, and whichever is higher will be returned as the output. This code, when submitted on LeetCode, beats nearly 41% of the submissions in terms of runtime and nearly 12% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.